Hey guys, I'm back with a new video. In this video, let us solve a problem on finding the second smallest element in an array. Now let us understand first a simple solution that we can use for solving this question. So the simple approach is to sort the array in increasing order. Let us say we are given this array. So the solution here is to sort the array in increasing order. So if we sort this array, we get the output as 3, 5, 6, 13 and 21. And after sorting, we can simply access the second element of this array, which is 5, and this will be the second smallest element for this array, right? So let us first solve this question using this approach. So let us define a function, second smallest, naive, and here we expect to get an array of elements. So the first thing we need to do here is we need to sort the array in ascending order. So for this we can say, let us define a constant, sorted elements, and on the elements array, let us call the sort method. And to the callback function, we can pass the comparator. So this will be our comparator function, element 1, element 2. So it compares two elements at a time. So element 1 minus element 2. And here let us log the sorted elements to the console. And let us define an array of elements right here. So 21, let me use the same array, 3, 5, 13 and 6. So 3, 5, 13 and 6. And now let us call the function second smallest, naive, and pass elements to it. And now let us try this out. To run the file, we can say node second smallest.js, press enter. And this gives us the sorted list. So 3, 5, 6, 13 and 21. Now we need to access the second element of this list. So let me comment this, const second smallest, and here we can say sorted elements, and access the second element using the index of 1, and let us return it right here. And now let us store the returned value in a constant. So let us call it as result and log the result to the console. And here let me use backticks. The second smallest element of the array is result. So now run the file, and this gives us 5 as the answer. So here let us call it as approach 1. Now let us understand the second approach, in which we will be using two traversals to solve this problem. Back to my whiteboard. So consider the same array, 21, 3, 5, 13 and 6. So in the very first traversal, we will find the minimum element, which is 3, and we will store it in a separate variable, say temp. Now in the second traversal, for the exact same array, we need to find the smallest element that is greater than, we want the element that is just greater than 3, right? Which in this case is 5. And for this solution, the time complexity will be order of n. So let us solve this question using this approach. So back to my Visual Studio Code, and here let us define a function, second smallest, to traversal. And here we expect to get an array of elements. So the very first step is to find the minimum element using the first traversal. So let us define a variable and let's call it as temp. And here I will first iterate over the elements array that we are having. So for let I is 0, I less than elements dot length, I plus plus. And here we need to check for each element that we get in the iteration. So elements I, so the element that is sitting at the index I, if that element, here let me set this to number dot positive infinity, elements of I. So the element that is sitting at the index I, if that is smaller than the temp, then in that case we can set temp to elements of I. Or we can also specify this exact thing using the min method of the math library. So temp math.min. Here I can pass two elements. So the current element that we are on, so the element that is sitting at the index I, and the temp. And here let us first check out if it gives us the correct value for the smallest element of the array. So the smallest element of the array is temp. So let us first run the file, the second smallest, two traversals, and here pass a list of elements. So let us use the exact same array elements, and here let us add a log as well to mark that we are running the second approach. So here let us say node second smallest.js, and this gives us the smallest element of the array is 3. So we get the correct output, right? So now we have the smallest element of the array, but our goal is to find the second smallest element of the array. So let me define a variable here, and let's call it as second smallest, and here also use different names. Let's call it as smallest. So set the second smallest variable to positive infinity. So number dot positive infinity. And now let us iterate over our array one more time. So using the second traversal. So for let I as 0, I less than elements.length, I plus plus. Now here we need to check if the element that we are currently on, that is the element that is sitting at the index I, if that element is not equals to the largest element, then we can compare it with our current second smallest element. So for the comparison, we don't want to compare the current element with the largest element, right? So this largest, not largest, it should be smallest. So for the current element, we don't want to compare it with the smallest element because the smallest element is already settled and we are interested in second smallest. So here we can say second smallest, and again use the min method of the math library. So element that is sitting at the index I, and here second smallest. And now let us log to the console second smallest to see what we get. So now if I run the file, you can see we are getting 5. So this is our correct answer for the second smallest element. So let me return this right here and collect it here. So const second smallest and log it right here. So the second smallest element of the array is second smallest. So this gives us 5, which is the correct output. Now let us do a quick try run for this code. Let me first remove these extra lines. And even this log as well. So let me erase this real quick. So 21, 3, 5, 13 and 6. So the first thing that we do here is to set the smallest variable and give this a value of infinity. So a positive infinity. Next we iterate over the list of elements that we are having. So then we use the min method on the math library and check for the minimum element between the two contenders that we are having. So smallest is currently infinity, and the element that we are currently at, which is at index 0, is 21. So 21 and infinity, which is the minimum out of these. So 21 and infinity, the minimum is 21. So now our smallest becomes 21. Next I gets incremented by 1, so I now becomes 1. Then we compare element that is currently sitting at the index I, which is at index 1. So 3. So 3 gets compared with the current minimum, which we got in the previous iteration as 21. So 3 and 21, and this gives us 3 when we pass these two numbers to the min method. So we get smallest as 3. Next, I gets incremented by 1 and it becomes 2. So the element that is currently sitting at the index 2 is 5, and that gets compared with 3 that we got as the smallest element in the previous iteration. So this also gives us 3. So in this iteration as well, the smallest is 3. Now I gets incremented by 1, so I becomes 3. Now the element that is sitting at the index 3 is 13. So 13 gets compared with the smallest that we got in the previous iteration, which is 3. So we pass these two to the min method and this gives us 3. So again our smallest is 3. Then we do an increment of I. So now I becomes 4. So the element that is sitting at the index 4 is 6. So 6 gets compared with the smallest that we got in the previous iteration, which is 3. So we again get 3 as our smallest element. And finally I gets again incremented by 1. So I becomes 5. And the list of elements also have a length of 5. So 5 less than 5 is false. And we come out of our for loop. So at this point, right after the for loop is done with its execution, the smallest is 3, right? So this is one part of the puzzle that we got the smallest element of the list as 3. Now the next part is to find the second smallest element of our list of elements. So we define a new variable second smallest and set this to positive infinity as well. So number dot positive infinity. Next we iterate over the list of elements that we are having, and for each element we check that whether it is equal to smallest or not. So for the very first iteration I is 0, so the element that is sitting at index 0 is 21. So 21 is definitely not equals to 3. So 21 will compete with the second smallest that we are having. So the current value is second smallest, which is our default one. So plus infinity. So math.min of 21 and plus infinity gives us 21. So after the first iteration, our second smallest comes out to be 21. Then I gets incremented by 1 and we go to element 3. So 3 is compared with the smallest. So 3 with 3 and these are equal. So we skip the if check and I gets incremented by 1 again. So now we go to element that is sitting at the index 2, which is 5. So 5, which is the element at the index 2, is compared with the smallest element, which is 3, and both of them are not equal to each other. So then we apply the min method on the element that we are currently on, which is 5, and the second smallest, that is 21. So 5 and 21, on applying the min method, gives us 5. So second smallest becomes 5 now. Next I gets incremented by 1, so it becomes 3, and the element that is sitting at the index 3 is 13. So 13 is compared with the second smallest, which in the previous iteration is 5. So 13 and 5. On applying the min method, this gives us 5. So second smallest is still 5. Then I gets incremented by 1. So I will now become 4. And the element at the index 4 is 6. And the second smallest that we got in the previous iteration is 5. So we pass these two to the min method. It gives us the second smallest as 5. Now finally the last increment of I happens. which means that I becomes 5. So 5 less than the element's length, which is also 5. The condition becomes false. We come out of our for loop and we return the second smallest, which is 5. And hence 5 is the correct answer. Now let us see the second approach using which we can solve the exact same question using just a single traversal. So let me clear the canvas now. So second smallest element using a single traversal. So what we will do here is that we'll find the minimum 2 elements in just a single traversal. So let us understand the approach first. So here what I will do is that I will create 2 variables. So a minimum and a second minimum. And set this to positive infinity to begin with. Now we'll loop through all the elements that we are having in our array. So let us take the same array. So let us take this array. So if the element that we are currently on is smaller than the minimum, then we will update the minimum and the second minimum. Else if the current element that we are on is smaller than second, then in that case what will happen is that we just update the second minimum, right? So if the element that we are on is smaller than the current minimum, then the element that we are on will become the new minimum, right? And if the element that we are on is smaller than the second minimum, then this element that we are on will become the second minimum. Make sense? So let us write the code for this, and it will make more sense once we are done with the implementation. So back to Visual Studio Code. Now before we code out our second approach, there is a problem in our first approach. Let us understand this. Now let us say if the array size is less than 2, then in that case we cannot find the second minimum element. Make sense? So let us add a check for that as well. So right here, if the elements dot length is less than 2, then simply log to the console second minimum cannot be found, and simply return like this. Now we will use the exact same check in our second implementation as well, that we will do using a single traversal. So let's define a function second minimum 1 traversal, and this expects to get an array of elements. So here let us first paste the check. So if the element's length is less than 2, we can simply return. Now here we need the 2 variables. So minimum, set this to number dot positive infinity, and second minimum as positive infinity, right? Now we need to go over the list of elements. So for let I as 0, I less than elements dot length, I plus plus. Now here we need to check if the current element that we are on, that is sitting at the index I, if it is smaller than the minimum, then we update both the minimum and the second minimum. So if the element that is sitting at the index I is smaller than the current minimum, then we can say second minimum will get updated to the minimum, and our new minimum will be elements of I because it is smaller than the current minimum. Make sense? So now we have our minimum element with us. Now if the element that we are currently on is less than the second minimum and it is greater than the current minimum, so in this case we just update our second minimum. So our new second minimum will become the element that is sitting at the index I, and down here we can return the second minimum. So let us call our function second minimum 1 traversal, And to this, we can pass our list of elements. And let us store the return value in a constant second min. So here let us check if the second min comes out to be equal to number dot positive infinity. If this is the case, we can log to the console there is no second minimum element in this array. Else we can log to the console the second minimum element of the array is, and here use the backticks and interpolate second min like this. So now let us run the code to see the output, and you can see we get the second minimum element is 5. So this is the correct output. Let us do a quick try run for our code. So let us see how this actually works. So let us quickly do a try run for our code. So here I will take some inputs. So 21, 3, 5, 13 and 6. Now the very first step here is to check for this condition. So if the element's length is less than 2, then we log to the console that second minimum cannot be found. Now this check will run for the case when we have an empty array or we have an array with only one element, say 3. So in these two cases, we cannot find the second minimum, right? Because in this array, we have no elements, and in this array, we don't have a contender for 3, right? So we can only find the second minimum if the length of the array is greater than or equals to 2. Next, we declare two variables. So we have a variable minimum and a second variable, second minimum. Now to begin with, we give them an initial value of positive infinity. So these are the default values for the start. Next we have this for loop. Now as long as I is less than element's length, so we will traverse over the list of elements starting from index 0 and we go on till index elements.length, which is for this example 5. So indexing will vary from 0 to 4 and 5 is exclusive, right? So for the very first iteration, the element at the index I, which is I0, so element at the index 0 is 21. So we compare 21 with minimum, which is the current minimum, which is positive infinity. So 21 is less than infinity, that is true. So we run these two statements. So here we do second minimum and set this to minimum, which is positive infinity, and then the minimum, so I'm representing it with capital M just for demonstration. This will be element at the index 0, so 21. So this is what we get for minimum and second minimum after the very first iteration. Then I will get incremented by 1, so I plus plus, and now I becomes 1. So again the element that is sitting at the index 1 is 3 and the minimum is 21 that we got in our previous iteration. So is 3 less than 21? Yes it is. So second minimum will become minimum, which is 21, and minimum will become the element that is sitting at the index I, which for I1 is 3, right? So after the second iteration, this is the status for second minimum and minimum. Now we increment I by 1, so now I becomes 2. The element at the index 2 is 5 and the current minimum is 3, so 5 less than 3. This check is false. So now we go to the else part. So for the else case, we check if 5 is less than the second minimum, which is true, and 5 greater than the minimum, which is also true. So this check gets satisfied and we set our second minimum to the element that is sitting at the index 2. So second minimum equals to elements I, right? So which is 5. And our minimum still stays at 3. So this is the case after 3 iterations. Now I will then get incremented by 1. So element at the index I is now 13. So let me write it here. And the current minimum is 3. So is 13 less than 3? No. So we go to the else part. And there we check 13, which is the element at the index 3. We compare that with second minimum, which is 5, and we check greater than the minimum, which is the current minimum, which is 3. So this check also fails, and our second minimum is still 5, and our minimum is still 3. So now we will do an I++, and now we go to 6. So is 6 less than our current minimum, which is 3? No. Then we go to the else part. Is 6 less than the second minimum, which is 5? No. So these two checks do not run in case of 6. So now we will again increment I by 1, and now I will become 5, and the number of elements in our list is also 5. So 5 less than 5 is false, and we come out of our for loop and we return the second minimum, which is 5. So this is how the entire code works. So this was all I wanted to cover in this video, where we discussed 3 implementations for finding the second smallest element in a list of elements. So the very first approach was to sort the list of elements and return the second element in the sorted array. So the sorting should be in ascending order. Second approach was to find the second smallest element using 2 traversals. And the third approach is to find the second smallest element using a single traversal. So let's catch up in the very next one.